And here we a little bit start. So we have all the time working with our system. Well, that's pretty nice. We're having a Jira. We have a lot of tickets there. We are very motivated as a developers to fulfill the expectations. So we do this, but sometimes not all things are getting well, especially when we are very close in front of the production time and trying to even, not even the production, I think based on my experience, I can even say refinement for the sprint. So and you're gonna show something to stakeholders and then you figure out, okay, nothing works together. So, or it works, but not exactly as expected. Or even stakeholders find a really improbable behavior that cannot be called as a feature. So we start to figuring out what is going on. And in the past, as everything has been located as a one big system, so there has been kind of nice common let's say practice to add logs and kind of punishing our main running application by adding more logs in order to understand what is happening with the system. We added more and more until we find the root cause, and then what actually happens is, because with having the logs, they're getting to be the penalties to the system. That's sometimes people even right now I observing on my team, so they don't realize it, that having something in the main thread or in the child of the main thread will penalize your system, even when it is just the log. So what is happening then? You reduce your performance of the system, you increase the latency. So that means even when you sometimes do the fix on your system, as a Java is by the nature concurrency environment, yeah, it will work just and it may happen, or I hope servers, when they remove the log, when they clean it up, they realize, okay, we are having the big latencies here, so they remove all these logs, and then it pop up some different kind of issues. Yeah, so it's like a never-ending story. It's still present, even those days, as I know that everyone wants to be on the hype and using the super cool technologies, but it's still there, yeah, and the same behavior is observed. So what we're gonna talk more today is about what is observability, because I've been watching also a couple of videos in order to figure out how to go with this topic, and yes, it's in somehow, and I have been reading also a lot of blogs and posts about this. What does observability actually mean? To make a system observable, it's kind of logical what it means. Okay, I get some measurement data of it. Okay, we're gonna touch it. We're gonna touch the difference between the monitoring and profiling and what kind of value it brings to us. We, of course, microservices. Everyone wants to have a microservices right here and right now. And what we can observe where, and we try to build some system and we try to observe it here right now. We try to run the system and collect some data and figure out whether we are able to find what is happening here and to increase our understanding of the system. So, what is observability? Okay, so this is, I think, well, I would say, what means having an observable system. So that means I can measure some data. I can kind of get some data out of it. In case of data points, I can do some graphs or charts which gives me some insights on the system what I'm dealing with. For example, where I'm experiencing very big latencies and where. Also, this was kind of what has been kind of puzzled me when I'm reading these blogs and observability, and this is more than monitoring or more than profiling, and this is some kind of ability to dynamically change your queries actually that you create the charts, of course, because you have a data points. For me as observability, just collecting the data points to have this ability, and based on the data points, of course, you create some common metrics. Of you create some, for example, you would love to have some logical stuff like how big is my heap, or what are my latencies on particular APIs, and you can aggregate this data. So, and those blocks are something, oh, observability is more than just creating a metrics. And then when I read this through, okay, so actually at the end, you would love to create something what you can observe, right? You can see, and the best thing is you basically create the metrics. It doesn't matter if you have something kind of statics, like a common one that are obvious, or you kind of playing at the kind of real time with the queries. So still you have a data and data points that you can kind of form in some kind of output. This is for me the observability. And yes, each kind of if you are following the pattern, and even if you run on premise, so each system have a different telemetry. Doesn't matter which kind of technology is used. It has a very different behavior, and each system, each point of you should do the different assumption of it, how it should behaves. But this means you should think on it. Well, recommend it. You cannot kind of generalize the similar behavior. So what we can observe, like of course hardware, containers, endpoint, even the libraries behaviors, if you are doing the updates of the libraries to ensure that the system is behaving similarly. And here it leads me to kind of highlight the differences between the monitoring and profiling. Monitoring is more about getting those measurements, getting those metrics, and getting the alerts. I think right now these days a very, very cool alerting system can be Prometheus, or you can add the Grafana here, which is difference between the Prometheus and Grafana is Prometheus is simply for collecting the data points and so on, and it doesn't allow you to kind of do the more sophisticated aggregation and display them in the dashboards as Grafana does, which you can export the data, use the Prometheus as a data source for those data points, and then create a nice dashboard, which Grafana offers a lot of plugins when how you can aggregate, how you can do the statistics, and so on, and to kind of visualize the data in the way you want. So this is why they are connected together. Profiling, at least. So if you have monitoring, it's worthwhile to have monitoring, yeah, because this will be probably the first signal. Okay, if you have defined the thresholds, how, for example, what is acceptable for you to take on particular endpoint, the response times, and so on, or what is a acceptable heap size that you can have, or something like that. If you have defined these thresholds, then you can set the alarms here, and you can of course you can even in Grafana to add some kind of additional logs. You can add here by using a log key and define another alarms here to be informed. So actually Grafana provides you the more features than the Prometheus itself, which is really like a data point queues stuff for collecting. Profiling, according if you have these alerts and so on, and you find out that there is a particular problem, so profiling, you are kind of get more granular samples of the data, like a more detailed view here. It costs more, I think, than just sharing some kind of logs or data points here, because you cannot. The point is, if you would profile everything all the time, right? You can generate a couple of gigabytes of the data. If you have, okay, it doesn't. For example, if you have like a one service, yeah, and you will send one data point per the request. That's cool. But what is gonna happen is, and you will say it each second, yeah, from some time, from some stuff. So it's very nice if you have one, but if you have a million requests and you will do this all these for a million requests, you can imagine how much data you need to go through and who will analyze it. I know that we are investing a lot of money to kind of develop artificial intelligence parsing or some in order to understand the data. Yeah, but anyway, this kind of amount of data that you are able to generate will be, I think, not too much for IE, but well, would make a sense because someone needs to pay anyway for the storages, for the transfer, and so on. So I've made, well, in many cases it's not sensible, and you can profile when you have the alert, you go and just put some kind of acceptable time frame and check it out what is happening here. So here, well, we're trying to with the microservices go to from many years right now. I know everyone is repeating this, like getting to microservice patterns. Like right now we separate each of them to a very single purpose system. We create many microservices. Then the companies have 100 services, which most of them, they don't know what is happening with them and why they are here. Someone forgets, okay, cool. And even when you know what is happening, especially right now, you need to observe data, you need to collect them to ensure that they are all stable and running as expected. But this is exactly what is here is, okay, so here on the chart, we have 4 services. Okay, one is getting bigger, let's split it. Okay, you split it into the 3 different services, and maybe it looks better for the manager. Oh, we have right now 3 instead of 1. Okay, but how you validate your hypothesis that right now the situation is better? How are you gonna measure this? Like, how? Like just saying, I don't think that it's enough. So this is the response of the community is exactly this observability and the monitoring and measuring and even the profiling here. That you can, okay, here I have, it's way better. We just achieve better latencies, and latencies are less because of this. And because of this, I gotta touch later. So we have this streaming pattern. Basically, most of the application are getting to be distributed these days. So if you think about, as we are here right now, JVM developers, the way how what we can observe is coming actually from the technology we are working on. And we know that the JDK, the Java Development Kit, contains the Java runtime environment, right? And the Java runtime environment contains the Java virtual machine, and Java virtual machine have some parts here. And aside of class loading, when you start your application, and there are a couple of class orders built on the hierarchy, yeah, that they loading the classes like from internal libraries, then they get your main project, load and create, fulfill the additional like a method area which is created at the start time. So you see here the answer, what we should observe and how and where we should pay attention is coming from the basic ground of the technology what we are working on. So okay, so we would love to measure the heap. Heap is a place where anything, the instances of the object, basically the classes, are reside, and here is running the garbage collection algorithm, which is kind of cleaning stuff we don't need, right? And on this heap, since the Java 8, there we have also the metaspace here. Before there was a per gem, so you've been maybe later before experiencing which kind of out of memory issues because now there was too small place, so you spent some time to set it up before. But right now it's a part of the heap, so you can unload the class on a fly and load it in, and it will be the information garbage collected. And there is a stack area. Stack area is also, it's a very interesting area because it's created per the thread. And as I mentioned it before at the beginning, so the JVM is a multi-threaded by the nature. So there are many threads running on the background, even when you have the main thread, right? There are like more than 10 threads, and definitely the threads, they are running as a daemons. Daemon means the thread which is ended when the JVM is ended. So that means even then, you see, we go back to the observability, because when we end the JVM, the virtual machine, and someone, for example, have forgotten to set the threads as a daemon, right? They will keep running in the background until they finish their job. And so, so you see here, it means, of course, if you kill the containers and so on, this is different. But if you are running some other stuff somewhere and they are just keep running in the cycle, this job, it will consume your resources. Yeah. So again, we need to observe this behavior. So anyway, the stack area created per thread, it has it actually has the methods references that is executed now is pop up at the top on the stack, right? When it's finished, it's getting out. When it's this is called the stack frame, that you can have the complete free of which kind of method has been on the bottom executed, or which kind of have been processed till the end. And okay, this is one part which is per thread, and then we have a native stack area. And here this is a tricky stuff, because there with the stack area, it's using through the JNI, the native interface, it goes to the operating system. What is nice on the Java is that actually that we have a heap, we have an object, we have these execution engine. Yeah, we have a bytecode, right? It's translated. But what is happening with the bytecode is that at the runtime, it's dynamically compiled by the JIT compiler to the application instruction, and this behavior is probably used as identified as a VORA, write once, run everywhere. But actually here you need to have a specific implementation of the JVM which is running on the system. So it's true, but with the limits. So here, see, the JIT compiler is actually dynamically compile the bytecode into the computer system instruction, and it can optimize. Yeah, and here, if you are, for example, having kind of messy code, or I don't know, let's say not well structured code, a JIT compiler will be forced to optimize it. So in order to achieve the good performance only because of your code, you need to run your application on the server for a certain amount of time. And if it is bad, not very suboptimal code, it can take a long time. But on this time frame where you don't have your optimized code kind of a little bit, so you will pay you can calculate it in the money. Yeah, so I think it makes sense to use design patterns or any kind of make your code cleaner. Yeah, then you can reduce your cost, especially, for example, in heap allocation, when you have the very known example with autoboxing, which can happen anytime. Yeah, not only because but because you have a library, you can allocate a more heap, like a bigger, and then you can, of course, you can calculate more money. So anyway, program counter here is per thread. It's a counter of the instruction which is right now executed. And you see here, everything is here connected. So everything this can we observe. And this is where we can observe everything. Based on my experience on here, we are developers, and of course we have JUnit tests. And some of us are using test containers in order to run the test against the Docker. Some of us run the Docker Compose application in order to generate some load and to ensure that some points working together. That's cool. So all this technology went, but there are still many projects they just use the unit test and a lot of mocks there, which are basically then giving. I'm not, no offense here, but you don't although you finished your ticket on the Jira is good, but if you connect all these together, you may very often get to the not nice surprises. Of course, and this is a funny thing, you have, aside of Docker Compose, where you can create your small services, you can run it up, and right now we have very powered systems, so basically you can have up to, I don't know, you can have on your laptop 64 gigabytes of RAM. Yes, so right now, so we are facing some interesting surprises in my presentation. So, okay, so you have enough resources most of the time to run these things and test it. So, and to collect the data points and shift them into your, you can import your dashboards or whatever and create some metrics. You can, of course, parse the log. This is the one what you can observe, logs, and traces. So here, what is the traces are, this is, one of you mentioned the Jagger or Zipkin. Yes, the traces are amazing, right? They are from the web application. They are able to identify exactly the flow through your root or of the microservices and see all the endpoints that are present in this trace. Okay, they can give you some kind of idea of what is happening with each particular request and how they are there. But maybe there is a one point what can we improve on the traces. I will touch it. Here, what I want to do, the traces are kind of, there's a span, right? They have kind of time frame from where the particular request have from where it begins, where it ends, and then it's go bottom here to the tree. Okay, you spend here this time on API, you get the authentication, you get to the database, you maybe just authenticate, you get to this endpoint, you are using a multiple databases, and then you can in a span, I think, also to get some what was had been happening here in the database, which kind of data you get back, and so on. So yeah, of course, it's a just individual requests, and you can just then aggregate some collections of those requests, and in order to get from I would say from the top perspective, the view, what is actually how your application behave. But this is on the surface. So it doesn't still tell you anything. You need to connect with this surface. You need to connect with logs or with the metrics, what is happening. And this is what we did, for example, when I've been trying to contribute to Open Tracing project, which is right now, I found it kind of few days ago, a part of, as I mean, part of Open Telemetry project, which is also the collection of APIs and SDKs, which kind of frameworks how you can observe again the system. So, and here I put here nice example that I did, just an example we present on one conferences, where you create the three endpoints that they communicate together. You see here on the trace, which is the span of the trace, which is a GET request, how it goes till the database, and how they are these red points. These red points, what we did, we just put into the span the ID, right? Each span has an ID. It's very unique ID. And what we did more, we sent the event, in this case, to the fly recorder, and the fly recorder gets this ID, and you see here on the bottom, by knowing this ID, I can, when I do profiling, yeah, I can then just take a look and then complete threads. I'll show you, yeah, and have complete over picture what has been really happening wrong. For example, there has been cycle, or there has been unnecessary iteration, or there has been autoboxing. So you see here, I get from the surface, which is for me the trace here, I identified there is something taking too much time here, and I go completely bottom into the JVM and get the information here by the profiling and figure out what has been wrong with this. And of course, in this example, there has been simply thread sleep. It's suspended thread and it has been waiting certain minutes, and this is why it is here those two span. And in this spans are these two very long time, like half a seconds. So, but you get a point how I get from the surface to the bottom. And here, what we have built on here will be, I have what I have seen on those presentations about observability. Everyone has been talking, but no one has been saying. But a lot of you have been saying, showing some examples. So in this process, I did a little bit coding, which I want to present to you. I have a Prometheus and Grafana, which I think a Prometheus is getting very big part of the market and collecting this point, similar to how to say, I have forgotten, micrometer. Okay, micrometer, which is used to collect the counters and Gaug, right, in order to get the measurements from the Java that we're gonna use. Grafana, of course, it's used, I think. Do you use something different than Grafana aside of Dynatrace or Datadog or something like interface? No, I don't think so. Me neither. So this is what you can do. What I did here also, I can create a Postman collection, right? And you can in Postman, just when you don't have any kind of load, you can generate and repeat the sequence more in order to get the load. So, but okay, that's nice. But I just use the Gatling here because Gatling is very cool, and it's great to create some order and also some order sequence of the events that should happen each request. For example, okay, I have logged in here successfully, I have filled out the form, or I have put here this thing, no, I have reached API, I get the response, I use the data from the response and fill out this and connect other response. So I can kind of do the data flow in the load, or like, I don't know how to say it. So data-oriented flow, load, data-oriented load. So, and what I can do is also use the fly recorder to get the data. That's what I'm gonna do. So in this case, we use the Java, Kotlin, and Scala. I used, I don't know, like most of you, as I ask, use the Spring Boot, but I see also a lot of people are using the Quarkus here. So what I will have, as I said, you can have a Docker registry, you can use Docker Compose, but most of people are right now deploying to the Kubernetes. Yeah, it can be the OpenShift or Kubernetes Cluster at the Amazon. So this is what I can do. And we generate some load. So let's run it up. So I have created everything into the script. So you see here, because I have created a script to building my Docker images, to push it into the local Docker registry, which I downloaded, and it's running there. So I have used the Kubernetes, the local one. So I check whether some other pods are running. So here I get pods. There is running already Grafana and Prometheus here. The reason why it's already running, because I already imported the boards I have created here. By the way, this project will be then published on our OpenValue Git repository, so you can check it out, so and try to play with it. Because the reason is I can compare. Actually, this is nice. I can compare different kind of behavior on the responses across the frameworks I have here, and I have put here into the project some most popular frameworks I think, or we think, or that some research diagnosed there as a Micronaut. It's not Ktor, which is more than Kotlin. In Kotlin, way popular. There's a Quarkus and Spring Boot. So, okay, so let's run it. I will deploy here. You can see I have here the Quarkus. I hope you can see here. So I will deploy the Quarkus ones, or not. I would love to deploy them. So let's deploy them. So they are probably here. So let's, yes, they are here. And you see, you have all these possibilities on your local computer when you can do all the stuff. So it's very hard only to start. Okay, so let's take a look. Oh, what is happening? It's okay. So this is not what I want to see. That's by the way. Okay, let's go here. So I have here the monitoring Quarkus and Java. So you see my endpoints are up here, but if I can show you last 3 minutes, you see I have been already playing with this. So this is why I have it. So I've been just trying to say it. So right now we have it up back again. So you can use the measurements here, you can use the alerting here, and so nothing. The Grafana gives you so many nice features, and I have forgotten. So let's make some load, right? This is not that much fun. So as I mentioned, then in Gatling, it's not hard. Yeah, even when you are the Java developers, they have a nice flow to create some simulation. It's basically all described there based on my experience. You don't have to have much. You can even, for example, in this case, I'm sharing the common libraries and common model which I use on the application, and I have imported here to my Gatling project. It will be also published there, and then I have created the simulation here. And here you see I have post and check. What is happening here? I get the post here, I get what I have post, and I verify whether it's properly stored by the checking. So it's kind of flow. You can do whatever you want with it. So you can ramp the user. I ramp the user 2000, but as you can see, aside of it, the Gatling allows you to put everything into the command line using, of course, Maven. You can add the properties and run there as a separate project here, and you can add it into your pipeline. So what I've been doing, so you can just really customize this framework in a way that you can put into pipeline, and this load will be happening. For example, we did it in a GitLab. So it has been built on the fly and so on. So it was very helpful to ensure that about our stability of the system by the small load. Okay, so let's run it. So you see here are happening something already. So here we got some load here, and what? Oh, what? Which one? Okay. You mean like this? Okay. So there is something happening each per minute. So you see it's getting high. So I don't know why the time responses are not happening, but they come. They come again. So okay, we wait a bit. What is nice here, as I told you, by knowing the understanding what is happening with these heaps, and so with a heap, you can create just really simple garbage JVM, GC or a page, and you can take a look what is happening, and you can see that I have increased the pressure on my heap around 20% here. So, and you see some kind of Nice. This is where the monitoring may get some really tricky. Yeah? You can see some kind of so places. It depends how often you receive the endpoints. Yeah, because the situation may look like this, or completely different. Yeah. So this is why the alerting, when you're doing the monitoring, the alerting takes a place because they okay ensure you okay man here's getting something wrong because this what I can see here may not really be relevant to the reality what we can record. So I have here the bots. Okay, I will check it out again. And as I said, what you can do here, you can go into your uh, very isolated environment, and you can take a look here. And how many of you know okay, I have here the simplest script which is creating right now that I will profile my application for around 2 minutes and I will create a new recording. What is great on the both I have a I will Quarkus Java. Okay, so right now recording started. So it's kind of initiating the recording here, and maybe Java platform provides you also many kind of very neat libraries or utils better. Many of you knows JCMD, right? Or is it something new? No, right? JCMD. This is very cool program because it allows you to connect to the Java process, right? Which you can verify a lot of other stuff like VM version which is running here. And you can see this is Java 17 here, which I can use for my just, I don't know, 18 or whatever other version here. And what is also is that you can ensure what is happening with your recordings. You just run, it's still running. Okay, cool. So I will wait until here.
Could you increase this size? Because I think that for the viewers at home it's hardly visible.
Okay, no, I'm sorry. Okay, so sorry, I'm not ready to increase maybe my fonts. I try. Wait a sec, I get idea. Here, change. So maybe here I can go to 20. I don't know whether it works, you know. No. Okay, so the command can right now definitely when I check now still recording is running. So what I can there is increasing the here. So we can go here and check the monitoring of our Quarkus system. You see here, for example, if I little bit you can see how much we can play here. What is happening here is this is a Java. I'm just curious why this not showing the heap committed from the Kotlin, because I have Quarkus Kotlin and Quarkus Java. Okay, but anyway, here it's definitely showing two responses. There are no, so we can here kind of add the new one. Sorry for that. Yes, you see guys. Oh, here there is a Quarkus, Spring Boot. Okay, so there is not Quarkus monitoring. So you see what you can do with Grafana, which is not very easy to do with how to say Prometheus, which is not ready for this. So right now I have apply. So right now I see the different behavior of the Kotlin. This is the Java. Yeah, how we use a heap. There is definitely something happening, and Kotlin is really different, really behaving differently, right? So it's, but although they have the same problem, yeah, it's auto boxing. So Kotlin simply increase the heap size like this, like a jump. But on the bottom, it will still show in very detail, with more granularity, that there is happening stuff. But you don't see it. But you see it just a jump here. And in Java, it simply shows some random points. But this is what will be happening. So that's what is happening. So here you see already some kind of GC allocation promotion rate. So right now it's over. So party is over. CPU is getting a little bit down. So this is all what you can learn about your system by observing. So let's put the stuff what we have measured here. I will ensure whether it's not running anymore. Yes, it's done. So let's ensure stuff here. You can here see that I have recorded stuff. I'm sorry. And I have basically here you can use the different kind of you mount your storage, right? Here I simply mounted from the Kubernetes to my local storage, but it can be S3, doesn't matter. The location doesn't matter, right? It's simply the storage system here. So, but you can already train it here. You can simply replace the link. You can use the environment properties to build. You can use our technologies to define the proper links to your storage system. But you see, here it's almost the behavior getting experience with cloud environment in your local system. Okay, so let's review it here. Let's run it out. So let's here. You can see here what has been happening here. You see here, but oh, okay. Before, let's go to the presentation because I've continued. Okay, so right now what I have done right now is that I run the system, right? Some kind of application independently in the Kubernetes. Here I have for the presentation purposes. Okay, I'm gonna run the Java one and how to say Kotlin Kotlin one to see the diversity of the languages. That's what we did in a Quarkus environment. So what I can do more here, and what I want to show here is we can go here. And let's undeploy this guy. Yeah, let's keep Grafana stuff. I have forgotten the command, and let's deploy the other ones here. Let's more stuff here. So this is what is amazing, what I really do like. So right now I deploy more. So when I go to Grafana here, okay, it's the gun, but here I can import a different, oh yes, save the dashboards. Okay, so right now let's see here who is going to be up there. Yeah, Quarkus. It seems that it's a bit lazy here. That's not up, although it's up. So Quarkus Kotlin. But I have forgotten what I have actually deployed there, but it should be up, some of them. So, but you can do this on a fly basically, and have the class your experience. Okay, so here that we already said that I'm using a micrometer here in order to get the data point after the JVM through the Prometheus, which is collecting all the data points, and I'm using the Prometheus as a resource for data points to display those on those metrics on nice charts. But I also show you how we can on the fly modify kind of nicely the experience, the chart, and where we are right now is we get some data. We created the event on here, and we collect the data. profile the application by using a Java file recorder. And we found out that this kind of application is, for example, wrong, something is happening here. So what I can do here is I can zoom this section. I know I don't still know. Okay, so I have a section and I can go take a look on the threads here, what is actually happening here, and I can identify here on my flame view. And as I oh, maybe right now it's getting okay. Yeah, it's, I have resized, I shouldn't do this. So I have right now. So right now, what I'm displayed, the Java file recorder allows you to not only kind of display the stack frames. This is what I even mentioned. What is happening, that the function goes on pop, and you can get the stack frame from the JVM here and display them. But it allows the JVM, the Java file recorder provides you the possibility to parse all those stack frames and put them into the flame diagram, so that you can see the kind of towers. And what is more interesting is, okay, maybe I need to run them again. Okay, I will run. What is very interesting in what we have done there in Java file recorder, you can highlight by the knowing a package the particular parts in these towers in the flame view. So I will show you again. So it crashes from whatever reason. It has been running very long time, and I'm using the development version. So, but let's put there some recordings. I can hear what I have here is a different recording. So right now it's, yeah, what is not optimal is that it holds all the memory stuff here. So let's take a look how it behaves. So okay, here we have the time frame. So let's select the selection, you see, and here we can go to the threads and see them, what they have here. This is the executor thread, and we can filter by the main. Oh, we need to find a good one here, and we can verify whether here you OpenValue, whether we have here in this thread. You see how many. What is interesting is, for example, Spring Boot initiate way less threads at the beginning than the Quarkus. Quarkus, from my part, I would say, in order to how to say, satisfy the workload, yeah. So it initiates so many threads. Anyway, it's like a JVM on steroids, but it is helpful until you have something which comes from the I/O operation, because I/O operation can break all these kind of tactics and gives you the penalties. Or when you make a locks and the threads, then they got stuck. Yeah, so it's nice, but it has some limits where it is not nice anymore, that it initiates more threads. In this case, aside of it, you see what you can have here is a kind of different kind of behavior of the garbage collections here. Because what is important, what you should take out of this garbage collection, autoboxing, it's fine, it's no problem, until it's causing the big pauses, because sometimes someone needs to clean it, the stuff, the heap, right? And if you have the big data here, the big objects that needs to be garbage collected, it causes the bigger pauses, and you can easily go to pauses which can maybe take minutes, yeah, and that delays. So those delays will be noticeable by your application. So here, why I put here this is a Java file recorder is running like a sidecar from here. It gives you very few penalties to your application. This is why this profiling is kind of very helpful, and you don't have to worry even when you profile the production system here. And the funny thing, it's push the events there. I will not have a time to touch it, but you can create, but you can find it on the web easily. It use the local thread buffers, which are very less price, and it transfer the data into the global buffers, and they are then stored in the repository. The issue here is that those repositories are just local. So of course you can use the streaming APIs, which is there implemented in order to push out the events there somewhere, but this is more again for monitoring purposes than for the profiling. So, but the micrometer, actually they use the same technique, kind of same approach, which use the same bar. He creates the repository where you put the counters and Gauke, but it's telling kind of and a different threads of your application, but it's still started from the main thread, so you get the more penalties than from here. But it's the most efficient tool, probably. This is now on the market, how you can share the data points. So right now it's something happening again. So here, right now, I have no screen. And right now you can see that here heaps can really resize very big, yeah, by simply this kind of behavior. And it can go, there are like a half second, yeah, but it can really turn into be couple of seconds that it can be noticeable. And although there are couple of small pauses here, but the summary of the pauses at the end you will be surprised how many minutes it takes of the day that your system has been paused. From 20, it can happen that from 24 hours the system went up, 1 hour has been paused because of garbage collections. So it makes a sense to see it, to monitor your system and having the ability to profile it. And right now it's way easier when we are getting into cloud and Dockerized, containerized environment and virtualized environment than has been before. And even before it was easier, but only a few people did it. So this is probably all from my presentation. We will share the presentation here. I have give you some links, but you can do this. I have keep publishing the articles on the FUJ about the new Java features and about the evolution of the JVM and Java itself. And the funny thing is, if I think back through, everything is sometimes somehow connected with observability. So everything, in order to understand, you cannot avoid this. You need to understand to the system. And from my personal experience is that understanding how the JVM works, which kind of parts has in execution environment, and the memory, what is the memory model guaranteed, gives you kind of very great hits what you actually should observe, instead of just writing some kind of queries and doing some charts which are nice. Of course, each chart is nice, which is visual, but it helps you to give a meaning to those charts and maybe just do the less and get more. Okay. Thank you very much for your time, for your listening. And if you have any question or you can share your experience with your system, yeah, feel free.
Oh, thanks, Miro. Well, actually, there came some questions via the chat, but first, the audience here, are any questions here? Yeah, please.
So at the beginning, you mentioned that logging or monitoring in general can cause performance penalties and so on. So what are your experiences in measuring the performance penalties caused by
Okay.
logging?
Okay, it depends on the kind of logs you have. Yeah, so if you have a lot of logs, as I said, this is running on the main thread, right? So every instruction you put into the main thread, it will be executed. So this automatically goes of the penalty. And if you put into the logging some kind of, I saw some put even the request to the service there in output, which has been connected with the database, right? So come on. So what will be happening? So of course you don't see it here, but if you profile by the I found it because I profiled the system by the Java file recorder, and I saw the readings, and the guy, where is it happening with this coding? The so much time that is spent because I allocate the event. So okay, I'll show you something what I thought that I will not have time, but you asked the question, so you get it. So how find it out? Something is happening with my screen still, but it's not because of me. Yeah, hey, even the IntelliJ right now crash. It's caused the crashes. So, but nevertheless, I allocate. I create an event, which I put the events across this some part of code. Yeah, this is what I said. There are the penalties of using a Java file recorder was not mine. I just replaced the classes, or you can do the agents what we have. So you can add the agent, which then will be just bytecode modification and create the events according to special methods here. And it's a very okay. I don't know what is happening here, but it's not. I'm not a god. It's not my ability. So here is a simple event. Okay, element. Oh, I don't have it here. Okay. So, okay, I go to presentation. There's something is wrong here. Okay. So here, I wanted to show here. I create the here event, and you can start the event in the here in the code. Just you instance the event and the start, and then the commit here the event, and this code goes to the buffer, and then it's shared, and then I can here and I can track the event. I say I will check whether I have one event here, which is here. Oh no, this, but anyway, it will be displayed here, and I can create here the event and check it out what was been happening. I can filter by the event. Can only go here, create the exact here, and then I go back here to the threads and trying to look up where it's blocking or what has been happening here and how the memory has been allocated and where. So yeah, so this is basically, I found that there has been a lot of places which has been suboptimal instead of looking to the code. So JFark leads you to root of codes very fastly, and you don't have to go through the hundreds lines of code or even thousands. Yeah, so that's my experience. I'm using a JFR in order to diagnose this most of the time. Yeah.
Another question from the chat. So a real life scenario. Sometimes a sub-process of a third-party library silently stucks or goes into an infinity loop. And the one asking the question is curious about the best practices to debug such a behavior or such a case.
Okay. Oh, this is amazing. So best practice is, okay, again, I'm not promoting a Java file recorder, yeah? So,
why not?
but the best practice is really do the simple reading. And for example, what I showed you here is on the chat. Maybe I hope you see it. Yeah. So we have here the pods, and if I go to the pod here, I need to go here. Oh, come on. Okay, I'm in a pod here. No. Oh, I need to connect to the pod. I can connect to the pod, and as I said, the Java provides you very neat JMCD util, where you can start your GR4 reading, and you can go 5 minutes of your GR4 reading. Yeah, I am right now in a pod, so JVM, I already show it, so I have here one running process, so I will connect it, and I can start the reading here. Yeah, so okay, basically I have here, okay, I had here, when it start blinking, I have here the command I wanted to show you. It's here. So what it does, because I love instead of repeating myself, I'm writing a script here. So I have here the start. You can start the duration. You can select the stuff. You can change the name. You can choose the setting profile. Yeah, because it gives you the more information from the GA4. You can parse, and I'm pretty sure that you will find out who is hanging there. It will be very obvious. So that's my best experience here.
Okay, thanks. Another question by Bert-Jan Schrijver. I'm curious about differences in the memory characteristics between Java and Kotlin. To my understanding, Kotlin code compiles to Java bytecode and runs in the same JVM and uses the same garbage collector. Yeah. So how does this lead to different memory characteristics?
Oh, that's important. That's I'm trying to find out. This is good, nice. Thank you for this question. So anyway, so what is seems to have, although they use the same JVM, right? I don't. Wait a second. Okay, I will add more stuff from the Kotlin that we see something. So although it's used the same JVM, so what is actually JVM? So there is a bytecode. It should produce a similar bytecode, right? The bytecode is then translated dynamically to the machine instructions, right? So there are 1,000 roads to Rome. So I don't know what is. I need to say I have a limited knowledge about the compiler of the Kotlin. Yeah, what I can see here. Well, I can only describe what I can see. So in this case, there is a running Kotlin code, and the Kotlin code is using the Java library, which has an issue, and it causes some pauses here. And although I know that this behavior has not been observed when I use completely Kotlin framework like a heater, yeah, it has been not visible here. The reason can be that the Kotlin compiler doesn't put the events there, so it actually does not collect much information, because what has been happening at the end is when I took a look on the pauses, yeah, in many cases the cater, although it's a complete pure Kotlin stuff, has been worse with the throughput as with the Java. So I don't know what is happening there. I see the memory allocation has been increasing, yeah, but I don't have I cannot answer this question properly. I've been trying to investigate it also, how Kotlin allocates it, but due to lack of time, I didn't put much more effort to do this. But Java is putting more internal event and doing more characteristic than the Kotlin thing.
Okay, so please promise that as soon as you find out, you write an article about it on our blog.
Oh, okay. I already did actually, but not exactly about this. I wrote the article about this, that actually, although the Kotlin does not show that it's happening, the garbage collection, it needs to create it create a lot of garbage here. Yeah, it has been not shown. It has been causing longer delays in the throughput by allocating the memory than the Java. Okay. So, but without more explanation, that was only observation. I don't know more details.
Okay, thanks. Any more questions?
I have a quick one regarding tracing the error and exception. So in regular way, I print the logs, I add some meaningful messages, then add the stack trace, right?
Yes.
With Java Flight Recorder, how does it look like? Is it like all the threads throw exception there, or?
No.
Could you please repeat the question so everybody at home?
Okay. How log looks? If I didn't understand, correct me, please. If I'm. How does look exception in a Java Fly Recorder?
Yeah, correct.
Because you are used to print the exception into the logs.
Yes,
Okay. So, and the stack traces into the logs. Okay. So, how it looks? There are, for example, exception field. You can take a look how it looks and who has been responsible, and you can, if you can of course take a look on the stack trace, which is not available in this moment, which is very interesting. So, but you can go from top till the end what has been actually happening here, and you see the stack trace can be here. We have it parsed, so it's very it's kind of nicer display than you can print into the command line, because I can go to different leaves. So
You missed the line numbers, or?
yeah. Oh well, if you use, there is a okay. There is a plugin to the Eclipse, so you can use the plugin into the Eclipse to GR4, and it can lead you even to the line of the code if you have it get into Eclipse. So you can just do the transfer, but in many cases it's not. I'm not Eclipse user. I am using Eclipse only for OpenJDK development, not for application. Okay. Yeah.
Thank you. Any more questions? Well, if not, then round of applause for Miro.
And use Fly Recorder, it's for free.
So, final promotion for the Java Flight Recorder.
Yeah.
Let's take a short break, and I'll suggest that we will be back live at 8:05. So some 10-minute break. See you then.
Thank you, guys. Thank you very much. I hope it was helpful. Some kind of.
It was. Yeah, welcome back for our second talk. We had a short break. As you see, the break is always too short, especially when there's beer being served. But there will be some more beer afterwards. Second talk is from Benedikt Neumeier. He's a senior member of our OpenValue team in Munich. And well, he developed himself a bit more into the direction of architecture, but what he really likes deep down below is still real coding and being busy with the technique. So without further ado, Benedikt, the floor is yours.
Thank you very much, Gerrit. So welcome from me as well. Hello, everybody together. I can say that that second talk is much more lightweight. It's definitely for after the break, so you can have a second beer or a third one. It will be much easier to recognize. Yeah, for me, I'm an architect, like Gerrit said. You can summarize my job that if I'm doing a good job, almost nobody noticed that the project was a challenge. And this is exactly what I'm heading for. And that's why I want to talk today again a little bit about best practice. And I want to motivate you to simply start doing things. And that's exactly what my talk is about. The implementation behind the talk was done mostly by Beto, a colleague of us. And since he already went pretty far with what he's done, we said, okay, let's make a talk out of it because it's simply worth to give people a hand in starting things. And this is what I want to show you. Let's see if this moves. It is. So when I was in lots of projects, and especially in that one that was not in such a good state when I started, and they needed somebody to bring that project back on the street or on a road with a vision or at least a probability so that they can succeed, is that in a very early stage of a lot of these projects, people had the sentence heard like, let us postpone or create something, that way we are faster. And this is always a very interesting sentence that makes me very, very suspicious when I hear that, because how can you become faster in postponing things, especially if you need them in the end? Deployment and delivery is very often something that is postponed to the very end. And I don't understand really what is in the mind of the people. When they're doing this, of course, there are always reasons for almost everything. And especially if you have to handle resources and have to do some demos to show your customer that you are adding value, you have to make certain priorities. But in the end, it is the faster what we are talking about. So when you say we are faster, you're faster in what? In simply demo stuff to the customer. Faster to fail overall, of course, if you're not able to deliver the thing. Because without delivery, you create no value overall. I think everybody would agree if you order in a restaurant the most finest dish and it's not brought to your table, delivery failed, nobody is helped. There's no value added to you. And I guess in the most restaurants, nobody would allow you in the kitchen because it's for staff only. And this is as well as in a certain situation we see sometimes in production that only the people creating the things are able to run it. And that's where you stop to create a product. That is stop where you having an interface where you can hand over. This is where you can suddenly get merged with your product or with your project. And in the end, this is then more and more likely to fail. And the failing thing is that most people not believe. And if you look around in the world, there are still a lot of projects that are in a critical state. And therefore, I just want to motivate the people, start changing it, start doing it differently, start following best practices. And you will see a very simple approach right after the few slides, because I think the more simple you think, the more likely it is you succeed. Yeah, in the bottom of the slide you see one of the famous sentences of the manifest for agile software development. Working software is the primary measure of progress. So what kind of progress do you really have if it's not working and working on production? Because working on the own PC, we already know this is not what you think that a story is delivered or a bunch of work or some task was finished. So working on your test environment, on your development environment is already much, much better. But then there's the question, how good, how representative is this for real production? And you have to find the little gaps in your ideas, creating something to lower the risk. So our highest priority is to satisfy the customer through early and continuous delivery of valuable software. That means if your planning goes like, I do in the first thing everything I know already, and then I try to use the rest to find out about all the stuff I don't know, then you have, in the end of your project, of your time, the most risk. Because you simply don't know what is there. There might be dragons. You might not even know if the stuff you did in the beginning will match the solution you create or to fill up the gaps later. So this is something that is not normally good matching together. We try to avoid this by having full-blown teams with full-stack development, to have teams that know as well about ops, to follow the depth of ops philosophy, to, from the very early point in the project, to try to make the whole breakthrough from the technique, from the very simple first running container in the delivery to the that looks maybe very similar to the very end. And delivery is as well something that is very often relevant to non-functional requirements. If you consider that your product in the end should have almost no downtime, then delivery is something you should train very early, because if you simply switch from one instance maybe then in the end to the other, the data must still be consistent. Production must still be able to be usable. And if you follow the modern patterns and become more and more asynchronous, this is something where you have to put much more brain into this, because the simplicity you get on the one node leads to a little bit more complexity in the whole cluster. So finding out what's really happening if you put one node out of the cluster and replace it with a different version is very, very interesting. So mitigating the risk and find out what works and what works not. It's the same here, what we have created for you. It's not perfect yet, but you see exactly what we know, what is working, because we have the whole flow, and what is not working yet, where we have the risk, where we have to learn. So we are more professional, the earlier we are deliver. So let's try to deliver early, valuable software, and we make very transparent and explicit what is not working yet. A lot of you might have already seen this typical risk management cross, where you maybe in the beginning or at certain checkpoints and milestones or end of sprints try to find out what might risk the delivery of your project. And I would say the worst both are these two, managed and accepted. Accepted simply means I can do nothing about it. When you talk about risks, you say a risk is something that you may imagine that will come in your way and will block you to go on or to even succeed. Maybe something that is so critical and so crucial that it will lead the whole project to die, to simply be stopped because it's not working to follow it, because some very basic assumptions in the beginning that lead to these projects are proven wrong, that they are simply not possible. And the earlier you find this out, the better it is. And the more simple you approach it, the less verbose your approach is, the more options you have, because everything you implement is narrowing down the solution space and will give you less options to find solutions. So that's why it's very important to go through the whole lifetime in the end of a software from the very beginning and consider if these steps can find and work out together or not. Here I have one of the sentences collected that I have heard during my project time. So, why we cannot start with deploying, why we cannot start with continuous delivery. So something like legal has not signed the contract. Oh yeah, what we are doing now, we're sitting around and waiting for somebody finding a pen. That's not an option, of course. Single sign-on is a classical subject matter that is postponed to the very last, but should be done very early to find out what kind of certification, what kind of technique is used, and how should an application or a certain piece that is integrated in the single sign-on be constructed or be designed that it will work out in the end safely. The last one is one you find very often in very huge organization. It's not working via VPN because you are somewhere and somebody is not allowed to open certain ports, maybe for a good reason. And that's exactly the reason why we are today here with a very simple, lightweight device that everybody should be able to afford. Honestly, if you are in a project and your project manager says, I cannot afford a Raspberry Pi, that one is maybe around $80, then you should consider not the gaps you don't know as the highest risk in the project, but your project management. So let's simply jump into it and start. What do we need? We need a Raspberry Pi, as I mentioned, $80, almost no power. I'm sure somebody will find a solution to easily power this with a solar panel. Then you need something very small, an SD card, because that's where the operating system of the Pi is stored. And I have here for convenience some universal multi-adapter tool, because my laptop has only 4 plugs and they all look the same. And this is something that you find out in the world that this is not enough, but makes the laptop, of course, very light and slim. So we need some compensation. I have here something with a cable connecting to the Raspberry Pi. I have something with a screen to see what's ongoing here. And that's why I will soon switch the screen that you can see as well. And this is then all connected. It's as well very handy to have a screwdriver because this housing of the Raspberry Pi, at least the one I have, or I already managed to put the card sidewise to the slot where it belongs and it falls simply into the housing. So I have to disassemble it, put out the card and put it together again. But this is something that is easy to learn. Okay, so I put my card here to the SD card reader and I will now switch after the next slide to my console because this is what definitely it's more interesting to run. And for that reason, I have to change to full screen. I hope this is working like expected. And you'll see. Looks good. So the first thing I would recommend to start, and this is as well what this talk is about, how to start, is using a version control system. So Git is the most common one, the one that is most in fashion. That means if you start doing something, try to work away. Okay.
Can it be blown up?
We can give it a try to increase the size of the shell.
Command plus.
Command plus is working. Oh, this is nice. Nice, thanks. So especially if we think about delivering things and want to make things reproducible, we are very fast at something like infrastructure as a code. That means you want to use a tool, maybe something like Ansible. We used Ansible for doing this. And of course, that way you can create your work in bunches of things. You can break it down, divide and conquer, very simple. And you can store everything. You can have different tryouts with different branches, and you come back, you can merge. This is what you want to do. So the first thing you should do when you start a project is git init or something similar. And for the second thing, I learned something new the last week. It's task file. It's a very simple lightweight framework that gives you the option to have a very simple facade to everything you want to do in your project. So what I did here, or what Beto did here, is that he simple breakdown from the very top, means a top-down approach, what kind of steps I might want to do when I set up a Raspberry Pi. So he started with the file, he wrote down the steps, and I can show you the file, how it's looking like. So it's just YAML, and you can write a command, you can write a description for the command, and here you can have simple real shell commands that are done. And that way you save a lot of time in not typing things wrong, because the real things are there written correctly, and the other things can be easily completed by autocomplete and tab. And this makes stuff really, really handy. And I think I will use this in future in every project or something similar, because I really, really like the approach. It helps you as well to keep on track, because you know exactly when you start with a top-down approach, what was your plan. So by simply maintaining this file, you are already self-documenting. You will know, okay, I had an idea that this is what I want to solve, and I can cut it in two pieces, so it's piece 1 and piece 2. And then you narrow down piece 1, and you simply still know what was piece 2, and it's part of the repo. So if you not work alone, but in a team, you can easily share, everybody can follow, and you have even a description if you simply write what it is. So I'm very lazy, and I knew that I have the second talk and maybe already with a beer. That's why I even numbered the things I will do now for you, or with you. So the first thing we want to do is we set up the SD card. Of course, we want to have some Linux on it. And now Ansible is running and setting up the SD card. And you can follow it and read it. And you know if it works once, there's a very good chance that it works a second time. So now he is asking me if I really want to format a disk, and before I do say yes to something like this, I normally check which disk is really meant, and this time I'm fine with it, so please go ahead. Then the most critical part is to remember the password, but yeah, it's working. And I'm afraid this is something we will see the most time of the talk. That's why we should start to go more in a dialogue. And I want to simply go from the last row to the front row, and you tell me what you waited last in your project for. So, Christoph, please, you.
What was last waiting for?
Yeah, what was you waiting for? When you were in a project and you could not go on because something was not there, what was it?
It was a Windows upgrade.
Thank you very much. Your neighbor, please. What was the last thing you had to wait for in a project that was annoying you? Sorry? Entwicklung, okay? So the software people itself?
I built the software for 3 months. I waited
Oh, okay. So it was just one saying that he was building a software for 3 months
And was deployed after 9 months.
and was waiting to get the artifact deployed for 9 months. So this is good. If you then a project manager and you plan 12 months development time and you get budget for 12 months for the people, because only after deployment you find out if it's really working, you know where the money goes wrong.
Yeah, waiting for FTP credentials from the vendor, yeah.
So waiting for FTP credentials was the answer. This is something as well that is very annoying because you almost know you're so close, it's just somebody has to open the door.
Yeah, correct.
Dino.
Waiting for other systems to do the integration test and find out if the functionality is sufficient.
Okay. That's as well something that should be automated. Integration tests, waiting for the feedback if something is really there, is it working, is it good enough, or if it's really worth to make a change of focus, to start something new, to improve the things.
Yeah. You can't prevent resource shortages in other teams, but you could specify the functionality and then stick to it and not be dependent on others to decide.
That's a very good point. So now we put this famous little card. I hope I this time find the right slot. Yeah, looks good. It has network, power, and everything else. And I now simply switch the screen to the other stuff. And now let's hope that it's booting. It makes noise, it's a good sign. Fingers crossed. Oh, it's moving. Very good. So we're ramping up the Raspberry Pi. We have our image there. It's of course only the very first step of doing things. But yeah, an operating system is already on the device. It's booting, it's there, and there is some Ubuntu, which is of course very blank, very simple, and it's asking for the login. This is something we not found out yet, how we can avoid it. So if you put an Ubuntu on the Raspberry Pi, okay, I was too early. It's asking you to change the password. Okay. So I change the password in an even more secret password. And here I am. So let's go back to the other one. Like this. It's coming. Hopefully. No. I think I put the right cable. Let's see. Okay, now. Back to the terminal. No?
Maybe it is just blank terminal. Yeah. That's why.
Hmm?
Just start typing, you will see something.
Okay, he is. Doesn't like that one. This is a bit unexpected. Sorry, I tried to fix it. Ah, here we are back. So simply let's do the next step, bootstrap. So what I want to do now, I want to change Ubuntu. I want to put in different users. I want to even switch off root completely and do some other configuration stuff. So you see here, replacing mod configuration, setting the time zone, create a user, deploy SSH keys. This is all the stuff a lot of people always still do manually, and you should get rid of it because it's not only just boring, it's as well error prone. If you miss one step in the middle, you debug a very long time and simply don't find out. So, okay, I give it one more try and switch back. Let's see what the Raspberry is doing. And he's moving as well. And it's maybe not so idle for a talk to show this because you have very few things you can talk about. But working like this is really convenient. Miro, what is your favorite project? Okay. And what in detail? Java Flight Recorder. Oh, I see. It's moving. It's very relaxed. And it will go through. It's booting. And you know, anytime I want to know what's really going on, I just go to the Ansible. And I not have to memorize everything. It's infrastructure as code, you know. I can work on it piece by piece. I can simply go through and I can extend it. And I can come back to certain steps if I want to find out how I can improve them and how I can get better. And I think it will even boot one more time after that. Let's see. Oh, this is already looking quite good. Ansible here is still moving. I think I can move back. And play with the screen. Maybe we can use the time and go back to the audience. So who of you in the project is already using continuous delivery or something like continuous deployment or have at least infrastructure as code? Start this time maybe on the other side. So what tool are you using for it? Terraform. For everything.
For everything.
Well,
we still need Java.
Okay, the application is Java, but the infrastructure is all in Terraform. So it's maybe mostly cloud-based or AWS, okay.
Yeah, there's Jenkins.
Jenkins, okay, for automation.
Yeah. What else integrated it? It is running on Kubernetes, so yeah, mostly this what I know. Yeah.
Next one.
Terraform for infrastructure,
It-
Kubernetes for the applications.
Okay. And how do you design the Kubernetes itself, how it should look like? Do you use some Helm charts?
Some charts, yeah.
Okay. Next one, please. Kubernetes auch?
Not a developer.
Okay. I'm afraid I have to play around with this display once more. And this is now the steps it takes most long. Upgrading all packages. It's around 5 to 8 minutes.
So each tasks are written
In Ansible, I can show you. So this is how the project structure looks like. So we have here the task file. I already mentioned that one. It's large enough, or it's?
Yes, okay. So each of them YAML files.
Yes. So I have here some certificates that belong to the image and so on. This is maybe not the best idea to put this in a repository, but this can be changed in the future. But for now, it was the most simple way to do it. So we just did it. And we could go to the next step. And how the certificates are then delivered in the next one, you can find out later. So what we have here is, of course, a lot of roles for the different steps. If you go maybe here to the task file a little bit down, let's say what set up SD card, what was in the beginning. You see this is just two command line things. One is calling the Ansible book. One is doing really the copying. More interesting is maybe something that is going on here. We have here the Ansible book play, so we can go to the play itself. You then find here the bootstrap one. It's here. So it's all a YAML. It says that all hosts of the Raspberry should be used with these roles. Okay, mod times one create user and so on. And the next one is the very same. It's totally similar. And yeah, it's still updating. And therefore, you can create a structure that you can share with people. Because doing something for your own is, of course, sad if it's just working for yourself. If you can share it in a team and you can work together, you need, of course, some sort of structure to split the work. And this is very nice to do with Ansible. You can even encrypt stuff. You can have your own vault. That way you can put passwords and similar things to the repository. And you have, of course, to find a way to decrypt it again. And you can start working with best practices from the very beginning. And if you then enhance this to really work on the production, it would most probably not be anymore something completely new, something you have to start from scratch, because you have already run through the things. You have learned about which models to use, which tasks to use, which libraries to use, and that way you have already done the most part or the largest part of the investigation work. Still updating.
So you're suggesting that developers should do Ansible scripts?
Yes, definitely.
Yeah, I've done that, and I don't like that. So
I prefer that my job ends when I have my image viewed and then I do the Helm upgrade.
It's a little bit like in a restaurant. Okay, you're in the kitchen. You're the chef. You like to cut things and put them together. You put them nicely on a dish, and then the waiter comes, who looks friendlier and has a smile, and that one is then going to the guest.
I've done both, but I think that it doesn't make sense to make this T-shaped developer very, very D.
Yeah, but if you're in a true DevOps teams, this is exactly what this culture is heading for, isn't it?
I've seen an approach where there was one person specializing on this.
Mm-hmm.
He was 1 per 70 people, and then he was doing this work.
As a service.
As a service, yeah.
And when he was on holiday, everybody was waiting.
No, everybody also had some knowledge, but not so deep.
Okay, so in the end, it was doing everybody, but you was one expert for consulting.
Yes, and our job was ending on this Helm upgrade minus E. Yeah?
Mm.
That was our part. And that was perfect.
And why didn't you like it?
I liked it.
Yeah?
I mean, I didn't like the Ansible because it's like, I don't know, you need to understand those rules and
It is a framework that has its own structure, of course. But you as well like Maven, don't you? Or Gradle?
I like to get things done and not, it's just a tool.
Yes.
Which helps you to do it.
So same with Ansible, isn't it?
So I think that if I have a Docker image, everybody can run it on their local machine, and that's already good enough.
Yes, yes. But of course, there's things you might not find out when you run it locally. But it's, of course, if it's working for you, it's a good approach. If your project is in time, if you can frequently delivery, everything is good. Of course, you can consider how you can improve, how you can open your horizon and become better, and maybe how you can find things more early. And latest when you come to cluster and things and you want to find out how the things behave when they break, you have then different things to do. The good thing is I can hand over this to a team member and can go to holiday and say, the rest is in the repo, that one is working. I keep my laptop and I give him this.
You can also write Docker compose, that also works.
It's possible, of course, yes. But then you have not physical network. You can go to different challenges when you go for it. And you even can hand over this to a customer and you say, here's a button, switch it off, put it to your network, and you can try out.
Was this used for a team which runs on-premise or on cloud?
If you run on cloud, of course, it might be not so much important. But what we do inside here is we run a Kubernetes. So we use cloud technologies on a Raspberry Pi. So it's like on-premise, like you should work on-premise today. And a lot of people today try to be in the cloud if it's possible, but there are lots of projects where it's definitely not allowed to be on the cloud because maybe you have a critical infrastructure, maybe you have still other stuff on-premise where you not want to go directly with a hybrid because you then have a security breach. And definitely for on-premise, it's much more interesting to find out and to use it. So if you are already fully 100% in the cloud and you can work with it, then, of course, it's a totally different situation.
I find a bit unfair that this DevOps developer needs to know so much more and to earn the same as a person who learned only React.
But if you do front end, you're an artist, okay. And if you're a full stack developer, you're an engineer.
Yeah, but in the end of the day, there is one tool, and here you need 20.
Yes, this is true. But the one who knows more can only sell as well what is needed. So you're doing React as well?
Yeah, I did it before.
And you like React?
I guess better than pure JavaScript.
Okay. And better than Ansible?
Yeah.
Knowing all these DevOps tools is good for CV, good for your CV.
Okay, but using them makes no fun.
I think there is some people who like using them.
For example, DevOps.
Yes.
But you know how to handle the bash, yeah?
Yeah.
Does this make fun?
I'm writing in JavaScript. Come on, you cannot compare DevOps and JavaScript.
I mean, hosting the database and Elasticsearch, things like that, it's not fun. It's just
Oh, we are ready with upgrading all the packages.
Fixing NPM problems is very fun.
I do Java usually.
Come on, maybe you're touching JavaScript.
So, since we are waiting anyway, does already had somebody questions? Is there something that we can talk about between the waiting time?
About waiting.
About waiting? Waiting is wasting, isn't it? Okay, I definitely found out that the next time I do a talk like this, I should do something like I have prepared this. You know this already for cooking shows, where you people not have to wait until the cake is really done.
Yeah, sure. That's why I did all the recordings before, just in case.
Just in case,
Yeah.
for your PC is breaking, because you always are on the edge on what was
Or
your...
just monitor if it's flashing or something. You know, the problems can come from everywhere.
But I think we are still inside of the 15 minutes for setting up the thing.
Yeah. Well, next time maybe make a video how you compile.
So I can move fast forward.
Yeah, exactly. Yeah.
Let's see, we can go back.
Or do you have which kind of Raspberry Pi? Do you have the fastest one you can have?
I think this is version 4.
Okay, it's too slow, right?
You think it's a Pi that is so slow?
Yeah. No.
I think that it's a overall upgrading of things.
Or next time we can do this in the cloud.
Oh, we are done. See?
Allocate a more processor.
So, next one is security. Of course, we want to have our own infrastructure installed. We want to have the things shut down. This is something maybe that is not so easily possible on your local container engine. If you really say, okay, now I close all the SSH connections for any user, unlike the one who is controlling this. And in the very end, when I have everything deployed, I really close it down, shut it down completely. That way, I can really try out what is possible with the security and what is not. And that way as well, you can try out if you have something deployed, if a certain bug is relevant for you or it isn't. So it's only 2 more scripts running, no worries, we'll come to an end soon. And I will show you that it's online.
Trying to understand why the Sensible is not so fun.
Hmm?
In JavaScript, you see at least something very fast.
We can switch through to the Pi. Let's see if it's more interesting to watch him. Who of you owns a Pi? We have 2 people saying yes.
I only eat pies, but
That's something else, right?
Who of you, when the last time did you set up a PC? Was it comfortable? Did you have to do a lot of interaction? Did you do it a second time?
Brew is doing it.
Brew is. And you have a script with all the stuff you need from Brew?
I don't know, like 10 commands and you're done.
But you have to type the commands separately? You have not a master Brew file with all your state?
Once you change the job, you type those 10 commands.
Next step is setting up the servers. So this step, we really run Kubernetes. And start it on the pile. I'm switching back and showing you. How often you have already deployed a Kubernetes cluster?
Few minutes before.
So Miro just did it a few minutes before the talk started.
Yeah, you need a command line, right?
Yeah, that's all what you need.
Yeah, you can have it on your iPhone.
You have a command line on your iPhone?
Yeah, yes, of course.
So we had been to server. And now we simply do apply. So here we are. And to prove that Kubernetes is running and we are connected, we have that one. And now comes the very last one. We deploy a most lightweight container in our Kubernetes cluster that is just reflecting the request we do. And I will show you in a second or two in the browser that this is working. And of course, you can get all the stuff online in the repositories. We will post the link later.
You are out of battery.
And I'm soon out of battery. Yeah? That's why it's important that this stuff is done in 15 minutes. You know?
So I read a book about Kubernetes some days back, and it was at the very beginning that never try to host a cluster. But I see some companies do it anyway.
Some people are doing this, hosting clusters, because, ooh, what's going on here?
Connection refused.
Connection refused. Okay. Most probably.
Ask for permission.
That one is still there. Just try it once more. There are still some glitches. Looks better. Almost done. Copying files, and if this is done, we are ready to go. Second time it worked, so it's just switch it on and on again, off and on again. Nee. Achso. So I already prepared the address. I of course put the stuff here in my host file to have the option for having a nice name for everything. So that's what I put it here. It's really handy. And I have it running without SSL, and I have it running with SSL. And that's it. Thank you very much for listening. Thank you very much for waiting with me. I hope it was no wasting.
Well, Benedikt, thanks a lot. There were some comments on the chat, so I don't want to that you missed them. Someone says, this may be one of the first Raspberry Pis ever to be live streamed to YouTube. Well, we've got that one. Yeah, so another one is waiting is wasting. We did some waiting, but I don't think it's wasting. It's quite interesting to see that with a simple solution you can actually create something and do something in a short time. And this is what I understand also reproducible in a big environment if you...
Exactly, so you can scale up. This is what you can do. You can start small, simple, without anything. You don't need a cloud for it. You don't need to know about a cloud, of course. And you can simply start. You can start automation. You can start thinking about how to splitting your project. And that is what is a big benefit. That is a gain. To start cutting it.
So what's the next logical extension that you see?
Of course, one Pi is very boring. Pis come in clusters. That's what's getting interesting. But having a Kubernetes cluster running on 2 Pis, running software on this cluster, seeing what's happening if you can disconnect both, how your application can handle a split brain, for example. This is something that is then where you can test your application to the edge if it's really stable, if it's really high-end, and it can fulfill the non-functional requirements that are demanded.
And could you do your profiling on that?
Yes, sure.
Would be interesting.
Yeah. Many harps verify the digital fly.
So we need 1 Pi for the profiler, and
or no, we need to like more Pis.
how much?
Boring. I don't know, 10.
10 Pis. Okay.
Yeah, you can build up the cluster, and run the application and connect each of them. Yeah, you can really build up the cloud like low cost. It's building on Amazon.
Not yet.
Not Google Cloud. No.
But you can mimic it.
Yes.
Any questions? Other questions from the audience?
Since we already used the time waiting to not make it wasting, somebody wants to add something? No?
Well, I want to add something to the end of this meetup, or at least also the part that's being streamed. Thank you for challenging the demo gods. I mean, it's always, if you do a presentation or a talk, most people only dare to do one little piece of real life demoing, and well, you outdid everything I've ever seen before. So, big round of applause for that.
Thank you.
And, please please, for everybody watching, please don't forget to like us and to follow us on the OpenValue channel on YouTube, where these videos will be posted soon. And for those looking, many thanks for watching. And for you here present, we still have, I think, per person 2 pizzas left, so you don't have to go yet. And there's something to drink. So thanks a lot.
Thank you for coming, and thank you for watching.